Welcome back to another rigid body problem. This is about equilibrium of rigid bodies. A ladder AB with a length of L, which later gives us 10 feet, and weight of W, which later tells us is 35 pounds, can be raised by cable BC. Determine the tension T required to raise end B just off the floor. In terms of W and theta, and if H is this much, L is this much, and W is this much. I'm going to just use solving it using those values. You could just get rid of values and do the parametric version if you'd like to. Equilibrium of a rigid body. First thing I do is draw a free body diagram of my rigid body. Step 2 is using equations of equilibrium. The three famous equations that we have in these cases, the 2D cases: summation of forces in x equals 0, summation of forces in y equals 0, and summation of moment about any point you want equal to 0. Decision you got to make is free body diagram of your rigid body. What is your rigid body? This problem is a little bit more straightforward. We can figure out that all the forces that's given and all the forces that are applied are just to the ladder, and as a result I have to draw a free body diagram of the ladder, and that is my rigid body. So let's do that. Free body diagram of the ladder. Step 1 of free body diagram is isolate the ladder and draw outline of the ladder. So let's do that. Let's remove platform A, pin A, pulley C, cable, all of that, and just draw the outline of the ladder. There we go. Step 2 is to put active forces and moments on the rigid body. I have point A, I have point B. One active force I have is weight of 35 pounds applied at G. G usually means center of gravity. In this case, it is also halfway through, so 4 feet. And that tells me that this is the center, and that's where I'm putting the force at point G, and it's always straight down no matter what. Cable T, you can take it as an active force, you can take it as reactive force, does not make any difference in your solution. I'm just going to add it right now. All right, step 3 is to put reactive forces and moment created by supports, constraints, stuff like that as a result of this rigid body be under applied load. Remember, important point, we are solving this problem when the ladder is raised a little bit off the floor. That means this ladder is pretty much like this. And this is the floor. So it's not touching. So if it's not touching, might as well the floor not be there at all. Doesn't make any difference, so there's not any reaction forces at point B. Point A, however, is a pin. I've had so many videos on this, and I've explained this, how to figure out reactions at a pin, but at this point we all know that pin has a horizontal component and a vertical reaction component as a result of restriction of movement. Doesn't have a moment because a pin, this ladder, can freely rotate about point A, so it does not create a moment. All right, I got to figure out some of the angles and the length that's given. So that's 10 feet. This is also 10 feet. So what that tells me is this triangle right here, this triangle here is isosceles, means this is 10 feet and this is 10 feet. So these two lengths are equal. So whatever that theta is, That means these two angles, let's call them alpha, these two also should be equal. So we have a little bit of a trig work to do. Here, I redraw this here. The quality is not the best, but I think it's legible. So let's figure out angle theta first. I have a triangle here of 8 feet. This is my ladder of 10 feet. This angle here is theta. As a result, this angle is theta. So let's see. Sine of theta, in this case, would be 8 feet over 10 feet. So sine theta is 0.8. As a result, theta should be 53.1 degrees. Okay, this is great. Now let's look at the isosceles triangle. Right here, 10 feet, 10 feet, 53.1, alpha and alpha. So 2 alpha plus theta should be 180 degrees. This is 53.1. As a result, alpha should be 63.45 degrees. And this is this alpha right here. You're going to see why I needed that. Because with finding that angle, because the goal is to find t. With one equation, I can just figure out my t. I don't need to find ax and ay. I can, absolutely. I have 3 equations. But if I write moment, summation of moment about point A, I should be able to just do one equation and be able to find my tension. This right here, which is perpendicular to the beam, is T sine alpha. So let's take moment of this force, T sine 63.45 degrees multiplied by perpendicular distance between point A and this force. I just found the perpendicular component, so that's the 10 feet, the ladder length. This is trying to rotate the ladder this way. It goes with my sign, so that's plus. The only other force I have on my free body diagram is this 35. Perpendicular distance between this one and line of action of A is this distance right here. So it's 35 pound or pounds. This perpendicular distance is half of this distance, so 5, and this angle was 53. So this distance is 5 cosine of 53.1 degrees. It's trying to rotate this way, which goes against my sign, so that's a negative. This should be 0. The only unknown in this equation is t, and if you do the math, you can find the t to be 11.7 pounds tension in the cable. Thank you very much.